Today's lecture topic is modes of heat transfer. There are three modes of heat transfer, that is conduction, convection and radiation. First one is conduction. Conduction, this is the mode of energy transfer as heat due to temperature difference within a body or between bodies in thermal contact without the involvement of mass flow or mixing. This is the mode of heat transfer through solid barriers and is encountered extensively in heat transfer equipment designed as well as in heating and cooling of various materials as in the case of heat treatment. The rate equation in this mode is based on Fourier's law of heat conduction, which states that the heat flow by conduction in any direction is proportional to the temperature gradient and area perpendicular to the flow direction and is in the direction of the negative gradient. The proportionality constant obtained in the relation is known as thermal conductivity K of the material. The mathematical equation is given by heat flow Q equal to minus Ka dt by dx. The units used in the text for various parameters are Q minus W equal to watt in area in meter squares. First one is conduction in plane wall. For a plane wall of thickness L between the two surfaces at T1 and T2 under steady condition leads to the equation to be considered as the mathematical model for this problem is Q equal to T1 minus T2 divided by L by Ka. Thermal conductivity is the constant of proportionality in Fourier's equation and plays an important role in heat transfer. The unit in SI system for conductivity is watt per meter Kelvin. It is a material property. Its value is higher for good electrical conductors and single crystals like diamond. Next, in order alloys of metals and non-metals, liquids have conductivity less than these materials. Gases have the least value for thermal conductivity. In solids, heat is conducted in two modes. One is the flow of thermally activated electrons and the second one is lattice waves generated by thermally induced atomic activity. In conductors, the predominant mode is by electron flow. It is equal between the two modes. In insulators, the lattice wave mode is main one. In liquids, conduction is by atomic or molecular diffusion. In gases, conduction is by diffusion or molecules from higher energy level to the lower energy level. Thermal conductivity is formed to vary with the temperature. In good conductors, thermal conductivity decreases with the temperature due to impedance to electron flow of higher electron densities. In insulators, temperature increases, thermal atomic activity also increases and hence thermal conductivity increases with the temperature. In the case of gases, thermal conductivity increases with the temperature due to increased random activity of atoms and molecules. Thermal conductivity of some materials are copper will be 386 watt per meter Kelvin, aluminum will be 204.2 watt per meter Kelvin and concrete 1.13 watt per meter Kelvin. Like this, the thermal conductivity will vary. Next one is thermal insulation. In many situations, to conserve heat energy, equipments have to be insulated. Thermal insulation materials should have a low thermal conductivity. This is achieved in solids by trapping air or a gas in small cavities inside the material. It may also be achieved by loose filling of solid particles. The insulating property depends on the material as well as the transport property of the gases filling the void spaces. These are essentially three types of insulating materials. One is fibrous, second one is cellular, third one is granular. Fibrous means small diameter particles of or flameless or loosely filled in the gap between surfaces to be insulated. Mineral wool is one of such material for temperatures below 700 degrees centigrade. Fiberglass insulation is used below 200 degrees centigrade for higher temperature refractory fiber like alumina or silica or viscose. Second one is cellular. These are available in the form of boards or formed parts. These contain voids with the air trapped in them. Examples are polyurethane and expanded polystyrene foams.